Why do centralized AI projects in large enterprises almost always fail? And honestly, why aren't we all fully automated yet? Welcome to this explainer, where we're going to bridge the massive gap between Silicon Valley's soaring expectations for AI and the incredibly messy, complicated reality of actually deploying it in a legacy enterprise.
Okay, look, it usually starts with this incredibly relatable boardroom mandate. The board demands AI, the CEO says, sure, I'll get a consultant, and suddenly there's this completely isolated, centralized AI project that nobody actually understands. Because it doesn't align with the day-to-day operations of the company, it inevitably fails.
So here is exactly how we'll unpack this collision course today. 1. Valley versus enterprise reality. 2. Hitting the integration wall. 3. The headless SaaS debate. 4. Managing scale and entropy. And 5. Why AI actually creates jobs.
Let's jump right into part 1. Valley versus enterprise. The reality gap.
Think about it like this. On one side, we have the typical Silicon Valley startup engineer archetype. Highly agile, immense technical aptitude, building tools from scratch, and instantly debugging as a single user. On the right, you have a typical enterprise environment. We're talking organizations older than 10 years, filled with thousands of employees, incredibly complex permissions, and brittle legacy systems. You simply can't take an AI built for that agile engineer and just drop it into a massive legacy environment and expect it to work.
Do you remember the early internet era's dead web? Every internal corporate team suddenly decided they needed a custom HTML website, but 6 months later, teams reorganized, people left, and these sites were completely abandoned. Blindly adding AI without structural alignment is literally repeating that exact same history today. It's just creating isolated, abandoned AI projects.
Which brings us to part 2, hitting the integration wall when dealing with access and permissions.
So, picture this. You're at work, and you realize you lack access to a specific document. You intuitively navigate what is actually a very messy, relationship-based process. You shoot a message to Sally to get permission. You casually ask Bob if the number in the database is actually the real, up-to-date number. We are great at this. An AI agent? Not so much. It doesn't know it needs to tap Bob on the shoulder. It just hits a hard access control wall, realizes it lacks permissions, and gets completely stuck.
This quote absolutely hits the nail on the head. An enterprise of 1,000 people, or one that is older than 10 years, is just a mass of stuff waiting to be integrated. AI doesn't magically bypass legacy security, messy data structures, or human governance to do that integration for you. It just doesn't.
Moving to part 3, the headless SaaS debate. Are we building for software or for humans? Right now, there are two distinct camps trying to solve this. One camp argues we need to strip away the user interface entirely for AI. The argument is that software must be redesigned with dedicated APIs specifically for machine users operating at massive scale. We recently saw major platforms like Salesforce announcing a push toward this headless infrastructure, treating AI as a totally new class of digital user that just pulls data instantly via APIs without clicking through any menus.
But here's the wild counterargument. The entire internet is already built and secured for humans. In fact, a lot of sites explicitly block headless scrapers. So to bypass anti-scraping measures, agents actually need to use standard browser interfaces. Sometimes, this literally means setting up a physical Mac Mini running Safari, just so the AI looks and acts exactly like a normal human user to the network.
And if we treat them like humans, well, they need to be managed like humans. An agent requires its own identity, an email address, and strict peer-level permissions to avoid monumental security risks. Actually, it almost needs its own HR-style orientation just to understand the specific company rules before it starts executing tasks.
Think about a robot trying to use an elevator. It can't just connect to the building's Wi-Fi and say, hey, take me to floor 5. Elevators don't have APIs. A company literally had to invent a physical robot to go over and push the buttons. Our digital legacy systems are exactly the same. There is no headless version of a 15-year-old corporate database.
This takes us to part 4, managing scale and the problem of entropy.
Now, just imagine 10,000 employees all unleashing their own AI agents to go do research at the same time. Suddenly, your corporate systems are getting pinged 500 times faster than normal. Think about that volume. Legacy network architectures simply were not built for that kind of throughput. It threatens to instantly crash the architecture of the entire enterprise.
To keep the wheels from completely falling off, enterprises absolutely must apply strict guardrails. Mandatory security reviews, extensive code reviews, hard throughput bandwidth limits, and staged production pipelines. Because of these incredibly necessary bottlenecks, that dream of a 10x productivity gain from AI, it gets throttled down to a realistic 2 to 3 times gain. And honestly, 2 to 3 times is still incredible, but it is heavily rate limited by the need for human review.
And that brings up the entropy problem. Yes, AI helps us build code and generate information incredibly fast, but in doing so, it introduces massive entropy. Because it's so fast, our systems become vastly more complicated than they were before. And a more complex system requires significantly more oversight, maintenance, and human management to keep it from collapsing. Finally, Part 5, why AI actually creates jobs by automating the baseline.
If we look back, history tells a very different story about automation fears. In 1965, people genuinely thought IBM computers would completely eliminate the need for accountants. In the 1980s, laptops were supposed to replace entire legal typing pools. In the 1990s, the internet sparked literal end-of-work panic. Yet, as we know, every single one of those technology waves resulted in massive job growth.
And here's why. Automating basic tasks just allows us to tackle much deeper complexities. When accountants stopped manually adding numbers on paper, accounting became highly strategic and complex. When lawyers stopped writing briefs by hand, the sheer volume and complexity of legal work expanded. Automating the baseline always raises the ceiling of what we can do. We will absolutely still need experts. Whether you are at an agile AI startup or a massive enterprise like John Deere or Eli Lilly, humans are required to kick off the processes, prompt the agents, review their work, navigate those messy inter-office relationships that AI just can't grasp, and ultimately incorporate that work into reality.
So, before we wrap up, let's do a rapid-fire recap of the hard facts we covered today. Number 1, enterprises older than 10 years or with over 1,000 people are a mass of unintegrated stuff. Number 2, AI agents and ping legacy systems 500 times faster, which threatens to crash them. Number 3, mandatory enterprise guardrails throttle the 10x AI dream down to a realistic 2 to 3 times productivity gain. And number 4, bypassing anti-scraping measures sometimes requires human emulation, literally like running Safari on a Mac Mini. Which brings us to today's core takeaway. AI isn't replacing you, it is creating a highly complex new digital landscape that only human experts can manage. Now I want to hear your take on the hardcore debate we mentioned earlier. Is running a physical Mac Mini with Safari so AI can mimic a human, a genius hack, or is it a massive architectural pitfall? Tell me your exact reasoning in the comments. And while you're at it, leave a comment below to grab our full tool list and mind map of today's explainer. Thanks for joining me, and I'll see you next time.